So the thing is that, what do you mean by meter
স্যার
bridge? হ্যাঁ, বলো।
স্যার আমার 5টার সময় একটা মক টেস্ট আছে, তো আমি 5টায়
হ্যাঁ
বেরিয়ে
হ্যাঁ,
যাব।
ঠিক আছে, no problem. So the thing is that is called, meter bridge, or এটাকে you can say is as a side wire, bridge. And what is meter bridge? This is a practical form of Wheatstone bridge. You can say that is nothing but the practical form of Wheatstone bridge. Wheatstone bridge. And of course it works on the principle of Wheatstone bridge. It works on on the principle of Wheatstone bridge. So the thing is that in that particular case, we know Wheatstone bridge, balance Wheatstone bridge is P by Q equals to R by S, and from that we can get, if S is the unknown resistance, then we can find the value of the unknown resistance by using the balanced Wheatstone bridge formula. So in case of meter bridge, what I am saying, it is nothing but practical form of Wheatstone bridge. That means in that particular case, if I try to draw the diagram, you will say that that is the corresponding diagram, and there is a connected 1 meter wire is connected like that, and the corresponding battery is connected like that. And what does it mean? That means there is a resistance, say R, and say there is another resistance, say S, if you want to calculate the value of S, and this is a middle point where a galvanometer is connected, and that will be connected with, this is a wire, and this is the jockey, and that should be touched with this wire. And when this balance condition will occur, there should not be any current which is flowing through the galvanometer. That means galvanometer shows no deflections. And if the resistance between the wire, if this is a and this is B, say the resistance between this is P, and the resistance between this can be treated as a Q, then what we that in that particular case, if R be the resistance, R, small r is the, if we say this is the resistance of the wire between, R be the resistance per unit length of the wire, per unit length of the wire, then we know P is nothing but, say the distance which I measure it, that is nothing but L. That means if the total is 1 meter, then the rest one is 100 minus L. So we can say if R be the resistance per unit length, then P is nothing but R is multiplied by N, and Q is R is multiplied by 100 minus L, because the total length is 100 centimeter. So if we, according to the, because the galvanometer shows no deflections, that means that will happen only when the Wheatstone bridge is balanced. So that means according to the principle of Wheatstone bridge, what we know, P by Q is equals to R by S, or S is equals to Q by P into R, or what is Q? This is R 100 minus L, and what is P? This is R into L, and if we multiply it by with R, this is 100 minus L by L multiplied by R. That is the corresponding. That means by simply knowing the value of L and R, we can calculate the unknown resistance. We can find the unknown resistance. That is the function of meter bridge. That is a simple function, and the problem that will also come, that is not, it's tough. And the thing is that uh, if you deduce something, if you make a note, then the thing is, if this r, if r is, that nearly equal to s, balance point of the bridge, balance point of the bridge will be near the, will be near the middle of slide wear. And the second thing that you can notice, that means sensitivity of this bridge, that is the, maximum when resistances, when resistances of all the forearms, all the forearms of the bridge are almost same. That the thing you can notice about that. Now if you can, you know just see a problem, that what type of problem may come from, meter bridge. Say the question is, if we say about the question, that means that is the simple, that is the same principle as Western bridge, balanced Western bridge, nothing else. Only the thing is that there is a 100 centimeter wear, and when the jockey touches the wear, it will, if the galvanometer will show, no deflections, then, the ratio of R by S is nothing but L by 100 minus L. That is the only the difference thing that you can, think of that. Otherwise the thing is that, the thing is same as, Western bridge network, that is same as, Western bridge network. So if we, deal with the questions, that means, say with a, you know certain, with a certain unknown resistance, with a certain unknown resistance x in the left back, left gap, and a resistance of 8 ohm in the, right gap. Null point is obtained. Null point is obtained on the meter bridge, where, and on putting another 8 ohm resistor in parallel with the 8 ohm resistor in the right gap, in the right gap. The null point is found by, the null point is found to shift by 15 centimeter. Find the, find the value of x from this observation. That is the corresponding questions. If you just look at the questions, then that is saying that with a certain unknown resistance X in the left gap and a resistance of 8 ohm in the right gap. A null point is obtained on the meter bridge wire, and on putting another 8 ohm resistor in parallel with the 8 ohm resistor in the right gap, the null point is found to shift by 15 centimeter. That is the thing. That means if this is a corresponding meter bridge, what I am telling that the thing is that are say connected to a meter bridge, and from that point a galvanometer is connected, and that is connected to the jockey L. And here there is an unknown resistance. They say this is X, and this resistance is 8 ohm, and null point is obtained, say if we say line point is obtained at length L, then what we know that X by 8 is L by 100 minus L. That is the corresponding formula. X by 8 is equals to L by 100 minus L. That is the, and now your question is on putting another 8 ohm resistor parallel with the 8 ohm in the right graph. If we say we are putting another resistor parallel to this 8 ohm, then the null point will be shifting somewhere else. I am saying that, that is, and it is given that null point is shifted by 15 centimeter. Null point is shifted by, so in the second case what we can say, this is that is a parallel, that means parallel combinations that will give you the resistance 4 ohm. 8 and 8 are in parallel, that will give you 4 ohm. That means X by 4, you can write L plus 15 divided by that should be 100. That means it is 85 minus L, right? Because the total is 100. So if it is shifted by 15 centimeter, it will be reduced by 15 centimeter. So if we just divided these two things, equation 1 and 2, the value of X will be cancelled out. So this 4 by 8, you can write L by 100 minus L multiplied by 85 minus L into L plus 15, and from that you will get L square minus 85 L plus 1500 is equals to 0. And the thing is that if you solve this, then L minus 60 multiplied by 25, that means 60 L minus 25 L plus 1500 can be equals to 0. So the thing is that L minus 60 minus 25 L minus 60. So the value of L minus 60 and this is L minus 25 is equals to 0. So either L would be 60 centimeter or 25 centimeter. And if we put this value into X, because the value of X is 60 and value of 25, depending on the if there is options, then you can put, otherwise if you put this in X by 8 is equals to either you can put 60, this is 100 minus 60, that means X by 8 is equals to 60 by 40. That means that will be come out 24 by, that is come out 12 ohm, right? And if we put this value X by 8 is equals to 25 by 100 minus 25, so that will come out something 2.67. so depending on the options you can select this. So স্নেহা, এটা কি বোঝা গেছে না কিছু অসুবিধা আছে?
না স্যার, বোঝা গেছে।
কোনো অসুবিধা নেই? নো চাপ? ওকে,
না স্যার, এটা ঠিক ছিল।
ওকে। সো কোন রকমের প্রবলেমে অসুবিধা আছে সেটা কি ফেস করেছেন, এখনো ফেস করেন?
হ্যাঁ স্যার, করেছি। খুব একটা প্রবলেম হয়নি এখনো পর্যন্ত।
ওকে, So before going that, I just forget to mention one thing. That is the thing, star delta conversion channel. No,
হ্যাঁ
জানো
স্যার
না।
কেটে গেল।
Star delta conversion. Star
না
delta.
স্যার।
জানো না। So that is also one of the important thing. এটা একটুখানি দেখে নাও, ভালো করে একটু বোঝার চেষ্টা করো, because that will come in competitive exam, in not in board, I think so. So that is called, delta, star conversions, delta ton, and that is actually used to solve, different types of applications in Kirchhoff's law. That means it may be possible that in some time you are experiencing great difficulty due to a, large number of simultaneous equations that you have to solve, and then this such complicated network can be, simplified by successively replacing delta mesh in equivalent star mesh and like that. So the thing is like that. uh, if this is a delta means the register are connected like that, the register are like that, connected like that. So thing is that, say I am writing this is, point 1, this is point 2, this is point 3. তাহলে রাজিয়া তুমি তো এটা জানো স্টার ডেল্টা কনভার্সনটা।
না স্যার স্টার ডেল্টা তো কখনো পড়িনি।
ও, এটা কিন্তু লাগে, মানে তুমি যদি ভার্মার বই খোলো বা বিভিন্ন রকম ম্যাথমেটিক্স বই খোলো সেখানে কিন্তু আছে। ঠিক আছে,
আচ্ছা
মানে এটা
ঠিক
তোমার
আছে।
সলভ করতে গেলে কাজে লাগবে, তুমি একটা প্রসেসটা দেখো তাহলে তোমরা বুঝতে পারবে যে সলভ করতে গেলে, মানে আমার যদি এরকম টাইপের ডেল্টা টাইপের অনেক নেটওয়ার্ক থাকে তখন হয়তো যখন ইকুইভ্যালেন্ট রেজিস্ট্যান্স বার করতে দিক বা কেভিএল সলভ করতে দিক, দেন কি হয় আমাদের কারেন্ট বার করতে বা যে কোনো কিছু করতে অসুবিধা হয়। তখন যদি আমি এটাকে ডেল্টা থেকে স্টারে কনভার্ট করে নিই, এটা আমার ইজিয়ার হতে পারে, বা উল্টোটাও হয় অনেক সময়, স্টার কনভার্সন যখন থাকে সার্কিটটা যদি স্টারের মতো দেখতে থাকে, দ্যাট উইল ক্রিয়েট এ প্রবলেম টু সলভ ইট। if we can convert it into a delta, then it should be okay। দেখ, আশা করি বুঝতে পারবে।
স্যার এটা কি থিওরেম?
এটা থিওরাম ঠিক না, বুঝেছো তো, মানে এটা এটা ক্যালকুলেশন, মানে বলতে পারো যেমন আমরা সিমেট্রিক একটা নেটওয়ার্ক বার করার একটা প্রসেস শিখেছি, এটাও একটা প্রসেস, এটা থিওরাম নয়। বুঝতে পেরেছো, মানে এটা থেকে এটা
আচ্ছা
আমি কনভার্ট করতে পারি উইথ দ্য, এই ইকুয়েশনসটা বসালে এটা থেকে এটা ডিরেক্টলি আমি কনভার্ট করতে পারি, এইরকম টাইপ। থিওরাম ঠিক বলতে পারো না। So in a particular, say this is a point 1, this is a point 2, this is a 1 2, and this is a point 1 and point 3, this is a 3 1, and this is a 2 3, that is the 3 resistance, and I want to convert it into, star network. I want to convert it into, say this is a star network, and the same point, that means this 1 point, this is a 2 point, and this is a 3 point, that means this is r1 and this is, r2 and this is r3. I am converting this point. So the thing is that, uh, I'm just you have to remember the equations, but how the equations will come, I just go through a few lines. The thing is that, if we want to find the resistance between 1 and 2, if I want to find, because you have to compare it with this, that means you are replacing the 1 2 terminal with r12, and the same thing when you convert this into star network, that particular resistance is r1. That means of course the r1 should be related with some r12 r23 and r31. How they will relate it, that we'll have to understand. That means first what we want to say, that means, I have to find the resistance, between terminal 1 and 2, resistance between terminal 1 and 2. If I want to find the resistance between terminal 1 and 2, you will see R31 and R23 that are in series, and the series combination is parallel with R12. So we can say this R12 multiplied by R23 plus R31, and, this is R23 and R31. And same thing, if we use the same terminal, one terminal and two terminal, you will feel that in case of star, this is the star network and this is the delta network, because it looks like a delta, it looks like a star. So between 1 and 2, the resistance is R1 plus R2. So the thing is that we can say this R1 plus R2, then we can say that should be equals to R1 to, that should be equals to this, because 1 2 junctions resistance is replaced in delta network that will be replaced in star network in the same junction. So I can say this can be written like that. So similarly the same thing, that means we will get R2 plus R3, that is also same thing, and also you will get R3 plus R1. You need not to remember all those stuffs. The thing is that if we solve this, then we will get the conversion. That means when you have to convert from delta to star, star network, then the star network resistance R1, this is replaced by R12 and R31 divided by R12 R23 plus R31. That is easy to remember. That means R1, you just see এটা মনে রাখবে কি করে, R1 মানে R12 R31, R23 টা বাদ. The thing is R12 Rn31. That means if we are calculating R2, that means you will see that R23 and R12. That means where the 2 is subscript is there, that should be there, and the thing is that you can write like that. And the thing is R3 is nothing but R31 R23 divided by say R12 plus R23 plus R31. That is the conversion delta to star. Similarly, if we convert it from the thing is that from start to delta, that means start to delta, if we convert it from start to delta, that means we have to find the value of R12, and this is nothing but R1 R2 plus R2 R3
স্যার এটা
plus
কিভাবে মনে রাখলে বললে একবার একটু বলবে?
এটা দেখো তুমি R1 টা আছে, দেখেছো তো R1 আছে এখানে, দেখো শুধু 1 সাবস্ক্রিপ্ট আছে,
হ্যাঁ
2
স্যার।
টা বাদ চলে যাবে, রাইট? মানে যে দুটোতে 1 সাবস্ক্রিপ্ট আছে সেটা আছে, আরেকটা কি আছে R2 3 আছে, তাই তো? তো R1 যখন বার করছো 2 3
হুম।
টা কিন্তু নেই, দেখতে পাচ্ছ? মানে
হ্যাঁ।
এটা যদি 1 থাকে, এখানে দুটো যে সাবস্ক্রিপ্ট আছে দেখো 1 এই থাকবে, এখানে যদি 2 থাকে তাহলে দেখো 2 টা আছে, রাইট? 1 3 টা কিন্তু নেই এখানে। এটা যখনই 3 আছে, তুমি দেখো 3 আছে আর 3 আছে, মানে এখানে কিন্তু 1 2 টা নেই, রাইট? আমি এরকম ভাবে মনে রাখতে বলছি।
আচ্ছা, ওকে স্যার।
আর এটা যদি মনে রাখতে হয়, এটা জাস্ট এখানে R1 R2 R2 R3 R3 R1 ডিভাইডেড বাই, এটা যদি R12 থাকে you have to divide it with R3. Similarly, if this is a R23, উপরের part that will be same R1 R2 plus R2 R3 plus R3 R1 and divide by, সেখানে 2 3 আছে, that means you should divide it with R1, and the difference R31, it is 9 R1 R2 R2 R3 plus R3 R1, that should be divided by R2. Now if we say that how we can find, that means say I am taking an example, then you will understand the thing. You can find different types of example in Varma where you have to use star delta conversions, that you can solve it easily. Any problem can be solved it. This is not an theorem. You can use in any problem. That is, say this is a thing is given, right? You have to find the equivalent resistance between A and B. Now the thing is that that is particular A, that is nothing but you can think of a delta connections. That is nothing but you can think of a delta connections. This is nothing but a delta connections. Now you just see, if we replace it, that means this is a 4 ohm. I am just replacing it with star. I am just replacing this 3 with star. Then this is 8, this is 4, this is the case. If we just replace it, then that two resistance, these two resistance are in series, these two resistance are in series, the combination are in parallel, and you can solve it easily. The difference you can do, you have to find, since this is the delta connections, and you have to you know you have to find the star connections, and that particular this particular resistance in figure, this is R1, this is R2 and R3, that means this is R1, this is R2, and this is R3, and R1 is nothing but, and this is nothing but, if we see the delta connections, this is R12, this is R23, and this is R31, right? So the thing is that I just replace the value. That means if we calculate the value of R1, value of R1 is nothing but, R12. R12 means 8, and R31 is 4, and divided by this 3, that means 8 plus 6 plus 4, that means this is nothing but, 32, and this is 10 and 18, and the thing is that this is nothing but 9 by 16, so this is 16 by 9. So R1 is nothing but, 16 by 9 we will get. Similarly we can get R2. If we want to find the R2, then what is the corresponding formula? R23, that is R23, that is 6, and R12, that is equals to 8, and divided by 18, right there. So this is you know right, that what we can say. uh, so this is 8 by 3, you can say 8 by 3, so this is nothing but 8 by 3. Similarly you can calculate like that, and if you can calculate like that, it can be easily solvable. That means if we want to calculate the R3, you can calculate. If you practice it, you can solve it in a minute, right? And R31 and R31 is 4, and R23 is 6, divided by 18, then what is the value? This, that means 4 by 3, that is 4 by 3. So this is 4 by 3. So now 4 by 3 and 8 that are in series, that means 4 plus 24 by 3, that means 28 by 3, and similarly 8 by 3 plus 4, that two are in series, that means that is 20 by 3, and that total combinations are in parallel, and that will give you, if we say this, that is that will give you something 35 by 9. So the thing is, the circuit is simple as that. This is 4, 16 by 9, and this is 35 by 9. So you can, there is nothing, so you can calculate it easily and you will get the answer. So that is one of the procedure by which you just convert the network from star to delta or delta to star. So that can be done in a different way, like that. A problem may be given like that. You have to calculate, say, the current flowing through, say, 10 ohm resistor, right? Current flowing through 10 ohm resistor, and it is given like that. Say it is, you know it will be given like that, say, and say this is 8, this is 4, this is 12, this is 12, this is 34, this is 30, this is 17, this is 30, this is 13, this is 10, and say this is A point, this is B point, this is C point, so this is D point, this is E point, F point, and the thing is that between A point and there is a battery of 180 volt that will be connected between these 2 points A and F. So this type of problem is given. If this type of problem is given, then you can convert it into star network, or from delta network you can convert it into a star network, right? So the thing is that, because that is the part that you can convert it, and that is the also part that you can convert it. So if you can convert it into delta, you will find the thing is that in that particular case, if we convert it into delta, I am not going to find the calculations, but the thing is that you can convert it like that. That means this, this and this is the star portions. Here there is 34 ohm, and this is also you can convert it like that. So this is nothing but a 10 ohm, you know that can be connected like that. So if you just draw the figure, that means you are just converting the thing into this circuit. That means this is a star, and this is a another star network. And if you can convert it, you will see that the circuit is the complicated circuit, you can make it as simple as that. So the thing is that that is the procedure by which you can actually convert the thing. So that is the beneficial of star to delta conversion, things like that. I'm just writing the value, you can calculate it in home, then you will find the value will come out like that. That means that value will be same 10, 10 and 10. So the thing is that if you calculate it, you can find the the result easily. So এটা হচ্ছে একটা স্টার থেকে delta conversions. And also there are some problem where you have to convert from uh, the reverse thing. That means the star network is given, if you convert it into delta, you can easily solve it. So the thing is that there is a procedure is different, there are different types of procedure are given, and you can convert it into easily to another procedure. So that is the
স্যার
conversion.
ওই 4 4 আর 10 10 গুলো কি ফর্মুলাতে বসিয়ে আসলো?
হ্যাঁ, ফর্মুলাতে বসিয়ে এসেছে। তুমি যদি
ওকে,
ফর্মুলাতে বসাও তাহলেই দেখতে পাবে চলে এসেছে।
ওকে।
তো সেটাই আমি বললাম তোমরা বাড়িতে করবে, বাট দ্য থিং ইজ ফর্মুলাতে বসালেই অ্যান্সারগুলো চলে আসবে। ট্রাই করে দেখবে যে কিভাবে কনভার্সনসটা, মানে জাস্ট ফর্মুলাগুলো মনে রাখাটাও খুব একটা ডিফিকাল্ট নয়। মানে তুমি এক দুবার প্র্যাকটিস করলে আমি তোমায় অঙ্কের সেটও পাঠিয়ে দিতে পারি, স্টার ডেল্টা কনভার্সনস, বা তোমরা যদি ভার্মার কিছু অঙ্ক দেখো কারেন্ট ইলেকট্রিসিটি, you will find that they will mention you that you have to solve it by using star and delta. অ্যান্ড তুমি যদি কটা প্রবলেম নিজে হাতে সলভ করো, অ্যান্ড আই থিঙ্ক ব্যাপারটা তুমি বুঝতে পারবে। মানে এটা কিন্তু কোনো রুল, এটা একটা প্রসিডিওর যেটা দিয়ে আমরা সিম্পলিফিকেশনের জন্য কমপ্লেক্স প্রবলেমকে সিম্পলিফিকেশনের জন্য ইউজ করতে পারি, আর কিছু না। বা আমিও তোমায় কটা প্রবলেম পাঠিয়ে দিতে পারি যেখানে ইউ ক্যান ইউজ দ্য স্টার ডেল্টা কনভার্সন, রাইট? So that is the one of the procedure. Now we can move to the potentiometer. I will send you some problem where you can solve it by star delta conversion. There are some definite problem is given. So if you practice it, then that would be okay. The thing is that, so now the thing is that uh, now there is a last thing of your current electricity, that is called potentiometer. Potentiometer. If your school is open, then you will see that that is the thing that you have to you know uh, there is an experiment in your lab that you have to do in lab. So the thing is that that is nothing but a potentiometer. So the thing is that what the purpose of this, that means potentiometer is an instrument that is essentially for measuring potential difference. So it is nothing but the potentiometer, the potentiometer the potentiometer is an instrument. Potentiometer is an instrument essentially essentially for measuring potential difference, for measuring you know potential difference, potential difference. So the thing is that, and it is simplest from you know it is in its simplest form, it consists a long and uniform wire. if we say in its you know simplest form, it consists of a long and uniform wear, long and uniform wear, and that will, you can say, material of a material having large specific heat, having large specific heat, and large specific heat na bole, that would be better if we say large specific resistance. And the thing is that, and low temperature coefficient, and low temperature coefficient, you know low temperature coefficient, and such as, you can say, such as manganese or constantan, that are the material which we can use. And of course, in that particular case, what will happen, that is a large specific heat for large specific resistance. That means if we can increase the temperature, the resistance will not change much. And low temperature coefficients, that means it will not increase the resistance depending on the temperature, whatever be the thing, that means that will not vary, the resistance will not vary with respect to temperature. That is the meaning of that. Now the thing is that what we can say about that, the potentiometer, it looks like that. That means, a wire is stretched on a wooden board that is carrying a scale of its length, and battery B, whose potential difference should always be greater at any voltage under measurement. We have to take a battery, you just remember, I have to take like that, and this is the corresponding battery that you have to connect it, and that is called rheostat. That means we can change the resistance, and this is the where. And the same case, that means, what I am saying, that a battery B, we are connecting a battery B whose potential difference, whose potential difference should always be be greater than any voltage, should always be greater than any voltage, any voltage under you know measurement, under measurement. And the thing is that that will maintain a steady current through the wire AD, that will maintain a steady current. As you know, the positive of the battery is connected to A point, the positive of the battery is connected to point A. So there is a fall of potential from A to D, right? Fall of potential from A towards D. And suppose we are connecting a cell of EMF E, that will be connecting to the positive, E is connected with a positive terminal of A. That means we are connecting, a cell of, EMF E, that will be connected to the positive terminal of A. The negative terminal is joined through a galvanometer to a jockey. The negative terminal that will be, joined through a galvanometer, you know, into a, say, jockey. That is the corresponding jockey. So the negative terminal that will join through a galvanometer to a jockey, which can be pressed at any point on AD. That can be pressed on any point on AD. Now say if a jockey is pressed at a point say M, say I am pressing at a point M. So the potential difference across AM, the potential difference when we are pressing the jockey at point M, the potential difference across AM, that will be less than the EMF of the cell. So the current flows in the galvanometer in the directions MEA, MEA, right? What I am saying, that means if this jockey is pressed at M such that such that the the potential difference, the potential difference across AM is less than the EMF of the cell, EMF of the cell. So the current flows in the galvanometer. So the current that flows in the galvanometer, say in the directions, in the say directions M E A, MEA, that directions. And say now if the jockey is pressed at point L, say the jockey is pressed at point, say L, say it will be pressed at point L, then in that particular case the potential difference across AL is greater than EMF of the cell. That means potential difference between AL is greater than EMF of the cell, and a current will flow in the galvanometer in the directions A E L, because the EMF that will be flow in A E L, because the voltage difference across AL that should be greater than the EMF of the cell, so the current will be flowing through the directions AEL. So thus and we will find, you just see in the pictorial diagram, the deflection when we are touching at point M, that should be in the reverse direction when we are touching at point L. That means it therefore follows that between M and L we find a point N. Between L and N, you have to find a point N, say this is a point N, such that when the jockey is pressed upon it, the galvanometer shows no deflection. There is no deflection when we are pressing at N, and the galvanometer shows no deflection. That means the current will not flowing through the galvanometer. Why? Because the potential difference across AN, that should be equals to EMF of the cell. If the potential difference between AN, that should be equals to the EMF of the cell, if there is a same potential difference, then there should be no current will be passing through the galvanometer. So what we will find, that particular E nothing but the potential difference across AN. And potential difference means if current will be passing through is I and R is the corresponding resistance, then we can find that E equals to IR, where this I is nothing but current through the potentiometer, where potentiometer where, and this R that is the resistance of its portions, resistance of its portion between A and N. That is the thing. So and also we know that resistance is nothing but R equals to rho L by A. So if we put this, A is the cross section of the wire, A is cross section of wire, and L is length AN, because you are finding the null point at N point. So we can write E is equals to I rho L by A, and you know that I rho by A, that is nothing but a constant. I rho by A, that is a constant term, I rho by A. So you can say E can be written as KL. This K is a constant and this value is nothing but K. I am taking that. So you can say that is E is equals to KL that we get, and L is nothing but the length when we get the null point. Now the thing is, a questions may come that whether we can measure the voltage accurately through potentiometer and through voltmeter, because by using voltmeter you can also measure the voltage across resistance or across anything, and by potentiometer you can also measure the same thing. Now the thing is, the potentiometer will give you more accurate result, because when you are measuring the the resistance or EMF by through potentiometer, you will find that there is no current will be flowing through the circuit, because when you want to measure, you are measuring the thing when the no current will be flowing through the potentiometer, and if the no current will be flowing through the potentiometer, there is no error, because when a current is flowing through the potentiometer, though there should be some small resistance, but since you have to calculate it, in case of voltmeter we have to passing the current, so when the current will be passing through the circuit, at least some resistance will be there, you cannot avoid it. So of course the potentiometer will give you more accurate result compared to the voltmeter. So now what should we do with the potentiometer? I am just giving you some example that is important. That means we are doing lots of things with the potentiometer. The first thing you can say, we can comparison. I can do the comparison of EMF of two cells, comparisons of the EMF of two cells by potentiometer, and that is easy, that is dependent on the circuit diagram. But the main thing is, if you understand the logic, that means in that particular case the EMF that you have to measure, that will be proportional to the length. That is the thing we will find from the potentiometer. So if we say that is a corresponding circuit, that means this is the battery, that means this is the battery, and I am I have to compare the EMF. That means there should be two cells. Say this is the cells and there is the key. Say this is the cells E1 and this is the cells that is E2, and what we can find, there is a galvanometer is connected like that, and this point, we can say it will be better if we write like that. That means this A point will be connected like that, and there should be like a in case of this is a where, nothing but I am writing the where in that particular fashion, and this is the A and D where, and that should be connected to the you know resistance right there. This is the AD. I am writing the same thing, right, but in a different way, and this is the galvanometer that will be connected to the wire at some point where we will get the null point. Say the null point is N. Say the null point is N. So in that particular case, what we have to do, if we say I am pressing this, I am pressing this one is open, so I am just connecting this particular button, that particular key, say key K1, then the current will be flowing like that from battery, it will goes this, it will goes this, it will goes this, and we will getting the null point, right? So the thing is, E2 is not connected like that. So for E1 you will get the null point and say this is KL1, right? And now you are just open this K1 key and you are just press this K2 key. That means the current will be flowing through the circuit, which is current will be flowing through the only for EMF E2. So you will get also some other null point. So that is say KL2. So now from this, if we measure it, that means E1 by E2, we will get L1 by L2. This is nothing but that. That means I can, by just finding the null point for two different EMFs of the cell, we will get two null point, and you just compare the ratio and you will get the answer. I think that is clear. Now the thing is that we can also do the same thing. That means we can compare the resistance. That means comparisons you know of resistances, comparison of resistances, that can also be done by using that can also be done by using this potentiometer. And you will find, I am not going through the details, this is nothing but you will get the resistance ratio is nothing but L1 by L2 ratio. And you can also measurement of small resistance that is connected to in series, that you can also measure through this. That means in that case we can measure, that means measurement of small resistance measurement of small resistance. That means the resistance, that means the small resistance, these are you know to the small resistance are to the measured to be measured to be measured is connected in series, is connected in series with a, say, known standard resistance, capital R. And if this happens, then you will find that the formula is like that: R plus R you will get by R, that can be L2 by L1, you will get that. And from that you can write R by R is equals to L2 by L1, or you can say R by R is equals to L2 by L1 minus 1, or you can say L2 by L1 by L1. So you will get the value of small r. If the question comes like that, that is nothing but L2 by L1 by L1. So that is the corresponding formula. That means if you can find the small resistance, we can do it by using this. And this experiment may be repeated by passing different current through R, and we will get the small resistance from this particular formula. And there is another thing that is also important for your syllabus, that is internal resistance. That is nothing but internal resistance of a cell, that you need to understand, that means that the cell E whose internal resistance is to be determined, that is connected in the circuit, right? That means what is the corresponding circuit? Same thing is that I am writing, this is the corresponding battery. There is a rheostat that would be connected to the wire length is D, and I am writing like that. If this is point A, and we know there is a wire that would be in that particular format, you can write a straight line also, that is the corresponding wire, AD wire. And what we can do, from this point A there is an EMF of the cell, this is the EMF of the cells, and there is we can just place a key K, and there is a resistance R, capital resistance R, and we are putting the galvanometer, and that would be connected to the jockey, say at some point, that point is N, right there. This is the same thing. So in that particular case, let let this E be the be the EMF of the cell, because in boards you have to write like that, and in E is the EMF of the cell, and this small r, its internal resistance, say this is nothing but internal resistance. And if the cell sends a current I, if the cell if the cell that sends a current I through the resistance, that is capital R. Then by using Ohm's law, what we will get, that E is equals to I R plus R. That we can get, that E is equals to I R plus R. And of course the potential difference across resistance R, that means the potential difference across resistance R, if this is given by say V, and we know V is equals to IR, that is the potential difference across this. Now if we find the ratio, that means E by V, then this is nothing but R by R by R, or 1 by R plus R. So the small r can be found by E by V minus 1 R. So that is, we are finding the internal resistance. Now say first this k is open, this k is open, this key k, what I am finding. So first what I am telling, that say key k is open, say k is open. Now if it is open, we are reaching a balance point n, and say this an is equals to L1. That means when k is open, we get balance point, that is an, say length L1. And of course in that particular case, when the k is open, when the k is open, the cells is not giving any current, so the potential difference across its terminal, that is equals to the EMF, because there is no resistance is connected there. So the potential difference across its terminal, that is equals to its EMF, and it is balanced against the length L1, it is balanced against the length L1. And if k be the potential gradient, what we will get from the first thing in potentiometer, we will get the value of A is equals to KL1. Now the K is closed. Now K is closed. Now if the K is closed, what we will find, so that the cell sends a current through R. Of course the cell sends a current through capital R, right? And the potential difference across its terminal now falls. So the potential difference across its terminals now falls to V, say. And of course we will get another balance point, so what we can say, V is equals to K of L2, that we can get. So E is equals to K of L1 and V is equals to K by L2. So if we write E by V, we will get L1 by L2. So the thing is that if we get L1 by L2, if we can put it into this formula, then the internal resistance that will come out, L1 by L2 minus 1, multiplied by R. So that is the internal resistance. We can also calculate the internal resistance from the potentiometer. So by potentiometer we can do lots of things, and you will see that what we can do with the potentiometer. So now we can solve some problems regarding the potentiometer. So first we will solve some simple problem, the potentiometer problem that are given, that are big. The thing is that the problem is statement is very big, but the answer is too small, the answer is too small. So that let's solve some problem. Say just a minute. Let's start with a simple problem. The problem is given like that. Say, mm, in a potentiometer, in a potentiometer arrangement, in a potentiometer arrangement, a cell of EMF 1.25 volt that gives a you know balance point at 30.0 centimeter length of the wire, length of the wire. If the cell if the cell is replaced by another cell, and the say balance point shifts to 63.0 centimeter, what is the EMF of the second cell? That is the simplest questions that can be formed by using potentiometer. That means in a potentiometer arrangement, a cell of EMF 1.25 that will gives a balance point 35.0 centimeter, and if the cell is replaced by another cell, the balance point shift to the 63 centimeter. What is
Sir,
the EMF?
2.25
Just
volt.
2.25, right? So that simple formula that we did already, E1 by E2 is equals to L1 by L2, because you are comparing the EMF, and of course E2 is equals to 63 by 35 into 1.25, and you will get 2.25 volt, right? So this is the simplest the problem that will be come from potentiometer. So the questions that will come, say, this is the corresponding figure that is given, you know that will be given like that, and it will be given like this is AB, and say this is E1 and E2, and say that means null point are given. If E1 and E2 is connected like that, this null point is given at 300 centimeter, and when their battery are connected like that, the null point we are getting at 120 centimeter from the end A. So you have to find the ratio of this, and position of the null point for cell E1, and how is the sensitivity, how is the sensitivity of a potentiometer increased. That is the corresponding questions. That means you have to find this thing. These are the corresponding questions from that particular figure. That is also easy. You can solve it and tell me the answer. বলো। এটা তো তোমার অ্যান্সারটা জানা উচিত। হোয়াট শুড বি দ্য অ্যান্সার? স্নেহা?
হ্যাঁ, বলছি স্যার। স্যার 7/3।
7/3, right, the ratio is 7/3. So how can you find it in that particular case? If you see
আর
the
210
210, right, 210, because this is nothing but, this is, k into 300, and this is, that is nothing but k into 120, right? Because that battery is connected like that, this is for negative and positive negative, and you will get the null point at 300 centimeter. If we can solve it, then you will get this ratio is nothing but 7/3. Now this is the first questions, and if we say the second part, that means position of the null point, you can put it anywhere, that means this is 300 and k, and if we put the value, that means you can say this, this is 3/7 into this, so 3/7 into this is 300k, and the thing is that if you can solve it, you will get 210k. So of course, the balance point that will get at 210, right, centimeter from it. And now how the sensitivity, that is the potential gradient we will feel, that is V by L, right? V or E by L, whatever be the thing, E equals to KL. So this is the E by L. So K is nothing but the potential gradient. This is nothing but the potential gradient. So lesser the value of potential gradient, that means lesser the value of potential gradient, more sensitive, more sensitive, you know is the galvanometer, is the potentiometer, more sensitive is the potentiometer, that we know. That means the sensitivity of the potentiometer that can be increased by, either we can increasing the length of the, if L is increasing, either if the length of the you know potentiometer wire is increases, then of course the value of L will be less, and if the value of L will be, K will be less, then the sensitivity is increases. And the second way I can increase is reducing potential difference, reducing potential difference across you know the wire, across the wire. That means E. If E is less, then K is less, right? So that is the way you can think of that, that we can uh, reduce this. So that is the one type of problem, and the potentiometer problem is too big. That means to write, right? That means it is too big to write. I am trying to write it right there. Say we will solve one problem, that is you know let's see. That means if the question is given like that, say two identical cells, say two identical cells of EMF 1.5 volt each are you know joined in parallel, each are joined in parallel, providing supply to an external circuit consisting of consisting of two resistors, two resistors of 13 ohm, each joined in parallel. A very high resistance, you know, voltmeter reads the terminal voltage of the cells to be 1.4 volt. Find the internal resistance. Find the internal resistance of each cell. So the question is two identical cells of EMF, that is 1.5 volt, each are joined in parallel, providing supply to an external circuit consisting of two resistors of 13 ohm, each joined in parallel. A very high resistance voltmeter reads the terminal voltage of the cell to be 1.4 volt. Find the internal resistance of each cell. So I think you can solve it, because if we want to find the internal resistance, there is a formula that we write there, that internal resistance can be written as E by V minus 1 multiplied by R. So if we write the formula, that means R is equals to E by V minus 1 into capital R. So in that particular case, you know the value of E is 1.5 volt and value of V is 1.4 volt. And the thing is that in that particular case, what is given, the two identical cell, because when you are writing identical cells, that means they are connected parallel combination of the cells, then net EMF is equals to the EMF of either cells. That means EMF will not change, that should be 1.5, and that will be connected, providing supply to an external circuit consisting of two resistor of 13 ohm each joined in parallel, each joined in parallel, and a very high resistance, that means each joined in parallel. That means, if we find it, then what is we will get if this is joined in, you know parallel. That means the value of R is nothing but 13 plus 13, 26, 2. That means this is nothing but 13 by 2 ohm. You just put the value. That means that is nothing but 1.5 by 1.4 minus 1, and this is nothing but 13 by 2. So if we calculate it, you will get this particular internal resistance value. That is a parallel combination. That means, that is a parallel resistance. That means Rp, because the two cells are connected in, parallel. So the thing is that this parallel resistance value, that should come out. You can calculate it, then you will find that. But I'm saying that because the cells, that means if this is a cells that has the internal resistance, if this is a cells that has the internal resistance, that means they are also connected like that in parallel. So what we can say, that this 1 by Rp is equals to, if the internal cell is R and this is R, then what we can say, right? That, so in the particular case we will get the individual internal resistance is 0.5 R. So if we place this 0.5 R is equals to 1.5 by 1.4 minus 1, this is 13 by 2. Then from we will get the value of R, and that will come out right there. So this is the corresponding answer. So আশা করি বোঝা গেছে ব্যাপারটা যেটা বলতে চাইছি, রাইট? না কিছু কনফিউশন আছে? So the thing is that the potentiometer problem is like that, and there are some variations, but but the formula, you have to put the formula, nothing but that. There is not a lot of variations from that. That means you have to just put the formula and you will get the answer. So the thing is that I am giving some tasks, and the thing is that then you can solve it